Um, Good day, guys. My name is Franklin. I know it's been a while, since almost 5 years now, since I posted a video, and it's been a long time. So today I will be making a video on the chemistry physics session, a section of the MCAT. This is something that I decided to do today because, first of all, I'm bored, and some of my friends have been asking me to make a video regarding, the cheat on how to read passages on the MCAT, how they can decipher, an MCAT styled passage without having to read the whole passage entirely or without having to, know the nitty gritty of the passages. So technically, I'll be sharing my secret to how I got a perfect score on this section. And let's go. So, first of all, the most important thing when reading an MCAT styled passage, especially for the MCAT CP section, is to understand that the question is what you're going to use to pinpoint the passage. You don't need to understand whatever is going on in the passage. You don't need to understand the whole scientific nitty gritty of the passage. The most important thing for you is to understand how can I use the information in the passage to answer the question that I'm being given. So it's like a puzzle, and I'm going to show you guys how to solve the puzzle. So let's start with this first question. The question was asking, what is the net charge of ST loop at pH 7.2? So for me, I haven't read this passage. I have not done anything yet. What I will do first of all is I'm gonna go to the to the passage. And by the way, this is a MCAT CP, I think full length 2 passage, if I can remember. I don't know where I got it from, but I know it's like it is the official double AAMC MCAT CP section passage. So for this question, it is asking for the net charge of ST loop at pH of 7.2. I don't need to know what ST loop is or whatever. I just need to know what about ST loop will pinpoint me to tell me what is the net charge of ST loop. So I'll go to the passage. I'm going to skim through, look for the first time they mention ST loop, and look around that specific portion where they mention ST loop, and see if I'm able to find some clues that I could use to deduct or to deduce the net charge of ST loop. So let's do it. So look at the first paragraph. Let's skim through. You see, we can't find anything as an abbreviation called ST loop. I go to the second paragraph. Keep moving. First line, second line, third line. Now, if you notice at the third line, the sentence that says, this sentence right here says, this synthetic T loop, ST loop was incubated, blah, blah, blah. So now I've already figured out where the ST loop is mentioned in the passage. What I need to do now is look around that ST loop. I'm going to read the sentence before where they mention the ST loop. I'm going to read the sentence where they mention the ST loop, and I'm going to most likely read the sentence after they mention the ST loop, just to cover all my tabs. And it's very quick. So let's read the sentence before this before the mentioning of the ST loop. The sentence starts with this. It says, a synthetic peptide with an amino acid sequence KTFCGPEYLA was generated as a mimic of the T loop. This synthetic T loop called ST loop. So technically they've given me the amino acid sequence called ST loop, and according to what we have there, they said the ST loop is basically, I'm gonna underline it out for you guys so you can see it is right here. So the ST loop is basically K T F C G P E Y L A. Now, we have already figured out what the ST loop sequence is, and they're asking at pH of 7.2. And we know that pH of 7.2 is technically the physiological condition or the neutral condition. So, and if you have a very strong command of the amino acid, most of the charges that we learn, most of the properties of amino acid that we learn in biochemistry is related to when it's measured in physiological condition. So That's another secret about the CP section. You have to know your amino acid. You have to know everything about your amino acid, including your charge, including their classification. What is the acidic amino acid? What is the basic amino acid? What is the neutral amino acid or the non-polar amino acid? And what are their charges? When something is basic, what is the charge? When something is acidic amino acid, what is the charge? So for this, the same at pH of 7.2. Now we're going to now start analyzing it. K is called lysine, and that is a basic amino acid. And basic amino acid at physiological condition, they have a net charge of what? Of +1. Now T is called threonine, and threonine is basically a neutral or a polar uncharged amino acid, which has a charge of 0 because it's neutral or polar uncharged. Now, F is called phenylalanine. Phenylalanine is a non-polar uncharged amino acid. Technically, it's just a non-polar amino acid. Also has a charge of 0. Now, C is called cysteine. Cysteine can technically be a polar charged, but at physiological condition, cysteine is a polar uncharged amino acid. So it has a condition of 0 as its charge. Now G is called glycine. Glycine is a non-polar amino acid, which most definitely has a charge of 0. Now P is called proline, and proline is a non-polar amino acid, which has a condition of what? In a charge of 0. E is called glutamic amino acid, which is an acidic amino acid. An acidic amino acid has a net charge of -1. Now, Y is called tyrosine, and tyrosine are polar uncharged amino acid when at this particular physiological condition. So tyrosine, we have a net charge of 0. Now L has a charge of 0 because L is also called leucine. Now A has a charge of 0 also because A is also called alanine, which are also non-polar amino acid. So they're asking us for the net charge. So the net charge of this is just going to be a summation of everything that we have here. So that will be +1 plus 0 plus 0 plus 0 plus 0 plus 0 plus -1 plus 0 plus 0 plus 0. So overall, the net charge of ST loop will be equal to 0. So that's why the answer to this question will be equal to 0. So that is how you are able to solve a passage. You see, I didn't know what is going on, and I don't care because it's for scientific nerds and all. But like, you don't need to understand whatever is going on to answer the question on the CP section. It's like a puzzle. So I'm going to show you other examples. We're going to use this passage. So let's go to the next question for this passage. Now, the next question says, in designing the experiment, the researchers used which type of 32P labeled ATP? Now, like I said, we just need to use the question as our clue to look for what to look for in the passage to be able to answer the question. Now, I'm just going to go to the passage and look for the thing I'm going to use as my clue. But don't forget, my clue is going to be where they mention 32P labeled ATP, because I don't need to know whatever is going on. I just need to know what about 32P labeled ATP. What about 32P labeled ATP can I use to answer the question from the passage? Now let's skim. Let's look at the first paragraph again. Blah 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 blah. We could see just a quick skim of the first paragraph. You don't see this 32P labeled ATP mentioned, so we can tell that the first paragraph is where we are not going to find our answer. Let's go to the second paragraph. You keep skimming. First line, second line, third line. In that same third line, we can see they mentioned 32P labeled ATP. And like I said, the cheat is whenever you see a passage, whenever you see the first mention of that thing we're looking for, you read the sentence before it, the sentence it contains, and the sentence after it. So that should be enough clue for you to be able to solve the question. Now let's read the sentence before it. It says a synthetic peptide with an amino acid sequence KTFCGPEYLA was generated as a mimic of the T loop. This synthetic T loop, ST loop, was incubated with a 32P labeled ATP in the presence of PDK1 for different time periods at 37 degrees Celsius and pH 7.2. And the amount of radioactivity incorporated into the ST loop was measured by the detection of beta minus decay. Technically, it's a whole lot of scientific jargons going on here. But what you need to use to answer this question has already been given to you. It says that it says it was incubated with 32P labeled ATP in the presence of what we call PDK1 at different times. So basically, they've told us the experiment that we are doing, and the experiment is that they're incubating ST loop in the presence of ATP. They've incubated it with ATP, which they have labeled one of its phosphoryl group in the presence of PDK1. So we now have to ask ourselves, what's PDK1? It's all about word soup, alphabetic scientific word soup. All I need to do is just scroll again. Look at where the passage mentioned PDK1. PDK1 is called, it was mentioned first here. It says it's called a 3-phosphorinositide dependent protein kinase. Now, there's something specific about kinase. If you have a very strong command of biochemistry, whenever you see the word mentioned kinase, that tells you what is going on is called a phosphoryl transfer. A phosphoryl transfer, right? Now, there's something about ATP. ATP has 3 phosphoryl group. That is why it is called adenosine triphosphate. Now it's like this. It has the adenosine nucleoside. It has the adenosine nucleoside. Then it's now connected to 3P group. We have the alpha. Then we have the beta phosphoryl group. And then we have the gamma phosphoryl group. This is something that you need to know from your basic biochemistry. Now, when it comes to a phosphoryl transfer of a kinase reaction, phosphoryl transfer starts from the gamma, then before it goes to the beta and before it goes to the alpha. Now, we could tell that because the question is asking that, the question said that we incubated this ST loop with the 32P labeled ATP. So basically, what the kinase will do, because the kinase is our PDK1, it's our kinase. What the kinase will do is it will kick off this phosphoryl group here and then transfer it into the stuff we're looking for. So the stuff is ST loop that we are transferring. So it's ST loop plus ATP that we are incubating in the presence of PDK1. So what will happen is this PDK1, we kick out this gamma phosphoryl group and transfer it to the ST loop. So it will now become ST loop will now be connected to the gamma phosphoryl group plus ADP. So that is what this kinase reaction will do. So our answer will be that in designing this experiment, the researchers use the type of 32P labeled ATP as the gamma 32P labeled ATP. Note that there is nothing called delta 32 labeled ATP because ATP only has 3 phosphoryl group. It only has the alpha, which is the closest to the nucleoside adenosine. It has the beta and then it has the gamma. The gamma is what we first kick out first before we now proceed to kick out the beta, and then we now proceed to kicking out the alpha. So that is how it works, and that's how you're able to solve this question. So you can see that for this question, you can only be able to solve this question if you are able to have a quick understanding of ATP, of the structures of ATP, which is very, very important. So like I mentioned in the first question, one of the things you need to know very well, have a very strong command of amino acid. Very, very strong command of amino acid. And also, for this second question, you need to have a very strong command of what we call the bioenergetics in biochemistry. And the currency for bioenergetics in biochemistry is ATP. This is like the MCAT favorite boy. They love it. This is like their dollars. This is what they love when it comes to bioenergetics. There is no question that I did on the MCATs when it came to the biochemistry or the CP section that I didn't have to deal with ATP. It always comes out. So you need to have a strong command of how the ATP works. Know the bond, know how they are connected, know them very, very well. So now let's go to the next question. Now the next question is saying, it says, when used in place of SPHM, which peptide would be most likely to achieve the same experimental results. I don't know. Like I said, I don't know what is SPHM, and I don't care. I just need to know what specific about SPHM will I be able to answer this question. What clue in the passage about SPHM will I use to answer this question that was presented to me? Now let's go back to the passage again, like we talked about. So in the first paragraph, let's skim through. First line, second line, third line, fourth line, fifth line, sixth line. I don't see anything mentioned as PHM. The only thing I see that was called PHM was probably this, but I don't see anything mentioned as PHM. So it has nothing to do with the first paragraph. Let's go to the second paragraph. Second paragraph says, to better understand, okay, first line, second line, third line, fourth line, fifth line, sixth line, seventh line. Now you can see in the seventh line over here, it says phosphorylated SHM, which is called SPHM, was used in place of SHM. So I know that this is where I'm going to find my answer. And what is our cheat again? We said whenever we see the first time they mentioned that statement, all we need to do is read the sentence before they mentioned it, the sentence where they mentioned it, and most likely the sentence after they mentioned it, if you haven't still found your clue yet. Now, let's read the sentence before they mentioned it. The sentence before they mentioned it says, this experiment was repeated in the presence of synthetic peptide that mimics HM domain, SHM, of serine/threonine kinases with amino acid sequence FL. Okay, you see, with amino acid sequence FLGFTY. They now said phosphorylated SHM. So basically, they're trying to tell us that SHM, let me use the white color pen. SHM, it's called, the structure is FLGFTY. They're not telling us that SPHM is actually the phosphorylated form. It's actually the phosphorylated form of SHM. And they said it's the phosphorylated form of SHM. Now, this is what I mean by you need to have a strong command of the amino acid. If you look at this structure, what part of this structure can be phosphorylated? There are only 3 types of amino acid that can be phosphorylated. And the 3 types of amino acids that can be phosphorylated are, you have the serine, we have the threonine, and we have what we call the tyrosine. So, and the reason why they can be phosphorylated is because the 3 of them all contain what we call hydroxyl group in their side chain. They all contain hydroxyl group in their side chain. That's, they have OH in their side chain. So that is why they can be phosphorylated. Now the question says, when used in place of SPHM, which peptide, so which of these options here would achieve the same experimental results? Now, let's break down SPHM. How would the structure of SPHM look like? Because we said SPHM is called the phosphorylated form of SHM. Now, what would be the phosphorylated form of this SHM? That would be that F cannot be phosphorylated, L cannot be phosphorylated, G cannot be phosphorylated because that's glycine. F again cannot be phosphorylated. T can be phosphorylated because that's threonine, right? So it's going to contain negative charge because phosphoric group contains negative charge. Phosphoric group is like this, PO3 4 minus. It contains a negative charge, so it can be. So it's going to introduce negativity to this particular structure. Y can also be phosphorylated, also introduce negativity to the structure. So SPHM, we have an overall structure that is negative. So its structure will be negative for the SPHM. Now they're not asking us, among these peptides that was presented in these options, which of the following peptide will achieve the same experimental result? Technically, they're just asking it that which of the following peptides here that we see here would have similar, they call it similar like structure or similar effect or similar effect. So, and in biochemistry, there are 2 ways you can find effect. You can find effect based of sterics or find effect based of electronics. We can see here that sterics is not really the big problem now. Electronics is the big problem because SPHM introduces negativity, so it changes the electronic structure of that particular peptide. So we need to find which of the following peptide that was given us here, which of the following peptides here who have the same electronic effect as SPHM. Basically, which of the following peptides here will be negative? That is what the question is asking us. So you need to know how to also be able to interpret it. So when you see questions like this, you just need to find the clues in the passage. The clues in the passage already told us that SPHM was used in place of SHM. So basically, and it told us that SPHM is called the what? The phosphorylated form of SHM. Now, let's look at each of the particular options. Now, first option A says FLGFAY. Now, none of these options has a negative charge because they are all polar what? Polar uncharged. None of these introduces negative charge. So none of this has a negative charge. So this one is out. Now we go to B. B says FLGFQY. Now, Q is also called glutamine, and glutamine does not introduce what's it called? Glutamine does not introduce, is it glutamine? I don't know, maybe it might be glutamine or asparagine, one of the two. But glutamine does not introduce negativity. It's also polar uncharged. So none of these options in option B will be negatively charged. Now let's check option C. Option C is FGY. These are all polar uncharged or what's it called, or non-polar amino acids. So basically none of these will give us a net charge of negative charge. Now let's now check option D. Option D is FLGFEY. We can see that E, our man, E is also called glutamic acid. And glutamic acid basically has a negative charge. So basically, glutamic acid is introducing negativity to this particular peptide. So this particular peptide will be a negative, overall negative peptide. And technically, that's our answer, because we are looking for, like we said, we are looking for which of this following peptide we have the same electronic effect as the SPHM. So technically, which of the following peptide would be negatively charged? So it brings our answer to option D. So, like I was saying, you need to have a very strong command of the amino acid. You see, by this question, once you have a strong command of the amino acid, you are able to know that there's something called what we call the phosphomimetic amino acid. So for this question, when I was doing it, I didn't even have to go through all this. All I needed to do was just look for what we call phosphomimetic amino acid. So basically, they are called amino acid that has the same effect as a phosphorylated amino acid. And there are only two amino acids that are called phosphomimetic amino acid. Those two amino acids are called the glutamic acid. Oh, I wrote glutamic. Hello, glutamine. Glutamic acid, which has a one-letter code of E, and the aspartic acid, which has a one-letter code of D. So these are the only two phosphomimetic amino acid, and the reason why they are called phosphomimetic amino acid is because they introduce negativity. That means they are negatively charged. They introduce negativity, like phosphoryl groups. And don't forget, like I told you, phosphoryl groups are written like this: PO3 4 minus, which is negatively charged. So basically, they introduce negativity, and that's why they are called phosphomimetic amino acid. And there are only two. So for this question, once you already knew that is something called phosphomimetic amino acid, that is all you needed to do to solve this question. Now let's go to the next question. Now, the next question, the last question says, based on the information in the passage, PDK1 catalyzes the addition of phosphate to which functional group? Like I already told you guys in the beginning, I told you guys that there are only three types of amino acid that can be phosphorylated. And I said the three types of amino acids are what? Serine. They are serine. We have threonine. And we have what we call tyrosine. These are the three types of amino acid that can be phosphorylated. And the reason why they can be phosphorylated is because they contain hydroxyl group. They contain hydroxyl group, which has like OH. It's like alcohol. That's the functional group on an alcohol. So basically, that is all I needed. But let's answer the question. The question says, based on the information in the passage, PDK1 catalyzes the addition of phosphate to what functional group? So I already answered the question, but let's use the passage again. Like I said, we have to first ask ourselves, what's PDK1? And just the first skimming of the passage, I could see PDK1 mentioned. That is the 3-phosphorinositide. I don't need to know whatever this alphabet soup is. This is the most important thing. It's called a kinase. And kinase catalyzes. They catalyzes the transfer of phosphoryl group. They catalyze the transfer of phosphoryl group. They catalyze the transfer of phosphoryl group from one and they use the currency called ATP. So they catalyze the transfer of phosphoryl group from ATP to our substrate of interest. So now they are saying, the question is asking, PDK1 catalyzes the addition of what functional group? So let's read the passage. The first line where they mention PDK1, what did they tell us? They said PDK1 phosphorylates specific serine or threonine residues in the conserved activation loop, still loop, blah, 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 blah. So they've already told us that it phosphorylates specific serine or threonine residues. If you have a strong command of amino acid, you should now ask yourself, what is specific about serine and threonine that PDK1 will phosphorylate them? And there's only one thing that is common between them, and that is the OH group. So that is why PDK1 will phosphorylate the hydroxyl group. So basically, how to answer questions like this on the MCAT is if you have a very strong command of your amino acid and you are able to use the information in the question to solve the question. So pick the information in the question, go to the passage, use the passage as your guide to now use that passage to answer the question. And that is what we have done. We've shown that in this question. We've shown that also in this question. We've shown that also in this question. And we've shown that also in this question. So the MCAT, the CP section of the MCAT, how I was able to manage to consistently get a perfect score both in my practice test and also in my actual MCAT is by following this cheat. I was never reading the passage. I didn't need to know the whole scientific nitty-gritty of the passage. All I need to do was use the information in the passage, use it to solve the question, but you have to first use the question first to guide yourself to look for what to look for in the passage. Like this video and comment whatever they do on YouTube, just do that. And if you want to see more, I'm going to be dropping more videos probably on the BB session. I was able to also achieve a great score also on the BB session and also for the psych soak, and whatever you want to see me do, just let me know. Thank you guys and have a good one.